For any linear transformation, we can also take or solve for the image and the pre-image using different vectors. We have here two linear transformations given to us. We have the first linear transformation defined with this, and the second is defined with this as well. Now, the image of a linear transformation is an element of the codomain after we have applied a certain vector that is an element of the domain. Okay? And then that is represented by this v, vector v here. These are the elements of your domain, and we have the image of this that are part of our codomain. This w, vector w's, are part of your codomain. Okay, so we're going to solve for its pre-images. So let's start with the first linear transformation. We are going to solve first for the image of vector v, then the pre-image of vector w. To solve for this, we are going to, of course, use this given linear transformation. We have the linear transformation of vector v, okay, vector v there, which is equal to the linear transformation of v sub 1 and then v sub 2. And in this case, this is our v sub 1, that's our v sub 2. So you have here the linear transformation of the vector v represented by 2 and negative 3. And then, once we are going to solve for its image, simply use this defined form here. In short, we'll have v sub 1, which is 2, comma, v sub 1, which is 2, plus twice your v sub 2. This would mean this is 2, that's 2 minus 6. So the image of vector v here is the vector with components 2 and negative 4. This is the image of your vector v. To solve for the pre-image, this is a little bit trickier because you're going to look at this relationship. Again, the image or transformation of vector v is defined here, transformation of v sub 1, v sub 2, which is defined as v sub 1 and then v sub 1 plus 2 v sub 2, right? This is the transformation, and this is equivalent to your w, your vector w here. So your vector w. In short, you will have here v sub 1, v sub 1 plus 2 v sub 2, which is equal to your vector w 4 and 12. Okay? And then we simply need to solve for the value of v sub 1 and v sub 2, which will comprise the pre-image of your, which is your vector v. So we'll have to make this equivalent because these are equivalent vectors. Your v sub 1 is 4. And then v sub 1 plus twice v sub 2 is 12. So we already have the first component, substituting that here. 4 plus twice v sub 2 is 12. Twice v sub 2 is 8. So v sub 2 is 4 as well. In short, the pre-image of your vector w is vector v, another vector v here, with components v sub 1 4 and v sub 2, which is also 4. Okay, so we have solved the image and the pre-images here. Now doing the same thing on next. Okay, so again, we're going to solve for the image of v and the pre-image of w. So the vector, the transformation of vector v, which will use the v sub 1 and v sub 2, is this one here, 4 and negative 1. With this, we're going to use this definition. So v sub 1, which is 4, plus v sub 2, which is negative 1, and then twice your v sub 2, which is negative 1. So you have here 4 minus 1, which is 3, and then negative 2. This is the image of your vector v. Okay? As you're just going to substitute only the components of vector v to get to this using this transformation. Now for our pre-image of vector w, again, this is how it looks like. We have v sub 1, v sub 2 equal to this definition, v sub 1 plus v sub 2 and then twice v sub 2 is equal to your vector w. Okay? When it's equal to your vector w, we simply use here the values v sub 1 plus v sub 2 and then twice v sub 2 equal to your vector w, which is 8 and 4. Equating it, v sub 1 plus v sub 2 is 8. Twice v sub 2 is 4. Using this, you can solve for v sub 2. V sub 2 is 2. Okay? And then using that, for our first equation, you have v sub 1 plus 2 is equal to 8. V sub 1 is equal to 6. This is the first component of your vector v. In short, the preimage of vector w is equal to a certain vector v with components 6 and 2. Of course, if you would like to make sure that your answer is correct or not, especially specifically in the preimages, you can substitute that here. So we have 6 plus 2, that's 8. And you have twice 2 is 4. That means your preimage is correct. Same thing with this here. The preimage is 4, 4, right? So substituting that here, 4, that's correct. 4 plus twice 4, 4 plus 8, 12 as well. That means your answer is correct. This is how we solve the preimage and image of a linear transformation. Thank you very much for watching.